Get that. All right. So this is just going to be probably a smaller tutorial on procedural generation. And yeah, attendance just not very much today. All right. So to start off with, what is procedural generation? It just refers to like some sort of method of creating like assets, maps, sound effects even, and so on, just like dynamically for the player. So while we usually think of it like maps, like a lot of this stuff shown here, it can still be other ways. Like for example, Dwarf Fortress, where it also generate like histories for all the worlds you make, for instance. Or as mentioned over here, planets and No Man's Sky. That's still kind of similar to maps, I guess. But you can really just do it for whatever. Like you could make like say like procedural animations actually is a common one, or like say for art assets. Not necessarily to be confused with AI art. That's different from this, I will note. All right. So then there's for why should you use it? Well, the simplest and often most common reason is that it can save you time and often money, since you don't have to spend all that time making all the individual maps or assets. Instead, you can make like a certain algorithm, whatever, to make like them like at one time for the players. So once you get it done once, you don't have to keep doing it. And the other reason is that it can sometimes create like unique experiences for the players, but there's an asterisk there because like you have to be very careful on how you make it to ensure that it will create different things every time that feels unique for the player. Like one way to kind of look at it is look at how people compare old Minecraft generation to new Minecraft generation. It used to be the older one actually had an error in how it was doing its noise, so it created a lot more varying landscapes that looked a lot more unique. But they eventually fixed that error later on, and it made it look more realistic, but it also lost some of that charm, at least for some of the players. So that's one thing to keep in mind. All right. And then there's for how do you make it? So the simplest way to think about it is that it's a mix of randomness and order. So in terms of randomness, you can have like noise, like there's some Perlin noise right there. That's often an easy way to make like a height map for something, since it has all the various peaks, but it also kind of has a slightly gradual transition between them. And besides that, you can also just use random number generators. Like we'll be using that a lot in this one instead to kind of make our own noise. But you can just use it for a lot of stuff, even just to choose like what you're going to replace it in. Speaking of which, in terms of placing stuff, usually you want some level of order in how it's done. So one of the simplest methods of doing order is like just smoothing. So let's say I took that noise, but I want to make sure the transitions were like a little more gradual. That's where smoothing comes in. I can make it so like say it averages everything around each pixel so that it becomes a little more gradual in those transitions. And additionally, you have like some sort of rules you can put in there, which is kind of why I show this image of Minecraft over here, since it shows them jigsaw blocks which are used where you have certain rules for how different assets can connect to each other based on those jigsaw blocks. So that's one way to kind of think about it, where you can be like, such and such object can only connect to another object based on certain conditions. So that can help you try and make sure your world generates, well, really whatever you're making generates how you want it to. And then of course there's like presets, where it could just be like, it'll just be putting something slightly random together, but there's large chunks of stuff that's already like well made, like hand designed. They're just slotted together by the computer, which you'll see in some games, like I believe Enter the Gungeon. I think that's how they do it. All right. And now we're going to go ahead and transition to the tutorial. So that was just to give a brief overview on procedural generation. So we're going to go ahead and open up Godot. Then we're going to create a new project. So just call whatever you want. I'm just calling ProcGen demo. Then whatever renderer you use is fine. We're just going to do create and edit. I'll just need like a minute, hopefully less. All right. So with that open, for like you download the sprite sheet. Are you also following along? Are you?
No.
Okay. So we're just gonna go ahead and grab that sprite sheet. Then we're gonna go to that file or that folder we just made. So I'm gonna go find mine. Where? Not that one. Here we are. And I'm just gonna plop it in there. Usually you want like a textures folder or something, but that doesn't really matter in this instance. All right. So we just want to make sure we have that spreadsheet 2D scene. All right. Then in that 2D scene, we're going to do add child node, and then do a tile map layer. At least, which version of Godot are you on? Are you on 4.3 or are you on 4.2?
4.3.
Gotcha. Okay, so you have tile map layer. So we'll do that. And then we're going to go ahead to tile set on the right. We're going to do new tile set. Then click on that. We're going to go ahead and change our tile size to 32, since this is a 32 by 32 tile sheet. Well, tile set. And then we're going to go to our bottom. Do you have those 32s in there? All right. So we're going to tile set on the bottom. Then you'll see that plus. We'll click that. We're going to do Atlas. And then you'll just grab your sprite sheet. Just do yes. And when you look in here, you should have your sprites in there. So we're not going to draw on the map ourselves, but if you just wanted to mess around real quick to make sure it works, you could like go to your tile map and start drawing them. But that part should work fine now. So with that little bit of setup, we're going to go ahead and start working on the code. So I'm just going to call this prop.gem code. I'm going to do create. And I'm doing this on the node 2D. If you want to do it on the tile map layer, you can. You just have to change a little bit how it actually does a few lines. But I just do it this way, so that way if I ever need to mess with the tiles, I can just do it directly in the one node everything's parented from. So we're just going to get rid of the process since we don't need that. And to start off with, we are going to make a tiles variable, which we're just going to set to just being an empty array. Then we're going to make a random number generator dot new. And we also need to make sure we have our tile map ready to like access. So we're going to do on ready. I'm going to call this var base layer equal, and I'm going to do that. So that's just so it's a bit easier to access our tile map layer, since you might want to have multiple tile map layers for different stuff. Like say this one's just going to be for the land. You might want another one for like trees and stuff and so on. So we're going to go ahead down to our ready. And first, we're going to check. All right. We're going to start off by making a v tiles done variable and set that equal to 0, which is basically just going to be keeping track of what tiles have been done yet in the vertical direction, since we're going to be making an array inside of an array for each of these so that we can have both x and y coordinates in there to make it easier. Since as far as I'm aware, there is no like matrix system in Godot, at least GD script. All right. So while vtiles done is less than 100, 100 is going to be our size, like in the y direction. So you could make that based on a variable if you wanted to. Then var h tiles done equals 0. So similar thing, the v tiles done, that's keeping track of the horizontal ones done. Then we're going to make a temporary, like, well, it's only an array, but I'm just calling it temp mat for matrix. And then while h tiles done is less than 100, similar thing, this is going to be the width of our map. And then temp mat append, and we're just going to add in zeros if we're just getting this started off. Tiles done plus equal 1. All right. So this little bit of code, what it will do is that's just going to make our starting array of everything, where it's going to loop through this like until it gets all the vertical elements in the first array done, and in that it's going to make each part is going to be a little temporary matrix where it's going to put in for 100 times, like again for that width, the like another blank tile in there. And I think we just need to make sure, yep, tiles.append temp mat. So just make sure to add it in there. And we just got to iterate. Tiles done plus equal 1. Yeah. So that finishes off that little bit there. And with that, we're going to go ahead and we're basically going to redo that sort of matrix again, since instead of making our little temp matrix like we just did, we're going to be instead make it so we're having numbers in there. So that one there is just so you have something you can start from. You could even just output just that as, like, say if you want like a blank ocean, for instance. But in this case, we're going to go ahead and make it so it has some random numbers in there. So let's see. We don't need the temp mat anymore. And that's going to be tiles, v tiles done, h tiles done equal, and then we're just going to give this a RNG randi, and we're going to do it from like 0 to 100. And then we're going to iterate like we did before, h tiles done plus equal 1, then v tiles done plus equal 1. So that'll make sure there's like a round number from like anywhere from like 0 to 100 inside each of those little spaces. Since if you don't know from GDScript, if you just do like your array, you index it there, that does like the array itself. If you index it again, it does the array inside of there. So it can work like your X and Y coordinates. So in this case, it's more like your Y than your X coordinates. So from there, since we have those actual random numbers, we're going to do for I in range 0 to 3, where we're going to start doing our smoothing. Since right now we just have a bunch of random numbers that's just going to look like some weird noise. So we want to start making it so we'll have some peaks kind of similar to like the Perlin noise we saw before. So we're going to have this running like, I think 3 times or something like that. This will like run multiple times to like smooth it out. So we're going to do I plus equal 1. And then first, we're going to copy the map that we have. So tiles.duplicate. And then we want that to be true in there. That makes sure that whenever we mess with this new map thing, it's not going to mess with the tiles one, since we're going to be referencing our tiles to affect the new map. And then like before, we can just go ahead and grab this stuff since we're doing that same matrix stuff again. And I'm going to go ahead and just make sure that's over a little bit. So I just copy and pasted this matrix, well, this chunk of code here to here, and then just put it over a little bit, since we're going to be working from that same stuff. All right. So from here, we're going to get rid of this because we already have our values. And now we're going to start trying to get like an average of like what the values are. But first, we got to put in some if statements to check for some like cases where if we tried to index either of the arrays, it would cause issues. So we're going to be making it so it can loop around. Like let's say if it tries to index something too high in the arrays because it's like a tile it wants to get the tiles to the right of it, but there are no tiles, we're going to make it so it loops back around to the ones at the start. Does that make sense? All right. So we're going to do if v tiles done equals 100 and h tiles done equals 100. So this is basically like when it reaches like the I think bottommost edge. So in that case, it's like it needs to go back for like all the stuff like kind of like on that corner of it and switch to doing at the opposite corner. So we are going to make it so new map, then v tiles done, h tiles done equals round, since we want to make sure we aren't just getting a giant integer. I mean, float each time. We just want to make sure it gets to an integer. So round. I'm sorry, this is not going to look nice. But once you see how to do it the first few times, it makes sense. So tiles, then v tiles done -1. Then h tiles done. Yeah. And then so plus tiles. And similarly, basically you can just grab this. We're just going to keep using this, since we're just trying to index all the tiles around this one. So instead of doing -1 there, well, we've already done the minus there. We're going to do a minus in the h. So basically that first one got the one like above it. This one gets to the like above and to the left. And then this one is going to be, actually, that one's going to be 1, because usually while we do like +1 there instead for this next one, we're doing just a 1, because this is the one that's like for the case where there's nothing to the right of it. So it's looping back to 1. Then we're going to continue. So instead, now we're going to get rid of this -1 here, since we want to do something just to the left of it. There will be signs to the left, so we can keep that how it is. Then plus, and then get rid of this -1 again that we just pasted. Instead of that, we're going to do a 1 again, because we would be doing just directly to the right, but we can't do to the right because, again, the same issue where there is nothing, so it's looping back to 1. Oh, hang on, I didn't realize I did that, my bad. There. Is this making sense? Do you need a moment to catch up on how it's working? Because it's like, let me grab the marker, I can try and illustrate it. Because you can probably figure out it's like yourself as long as you have L1 first one done. So it's, let me do it. So it's like, let's say you have some marker like 1, 0, like a 5, 6, 7, 8, 2, and like a 9. So let's say we're trying to get like the average of all the numbers around this 6. So this one here would be, if you subtract like from where that 6 is, do like a -1, and then you do a -1. This one here, that'd be -1, and then you're just gonna leave that like whatever it is for the 6. So if the 6 is like just h tiles done, then you put just h tiles done, no minus or anything. Next one, -1, and then instead of doing like, say, we usually do like a +1. Instead of doing like a +1, we're going to just do a 1, like for the entire thing, because there's nothing to the right. So you kind of continue this down where there's nothing over here, but then you do like a 1. It's not showing. There. So nothing there, but then a 1. Then you do like a +1, then a 1. And those ones, it's like similar to that one, where instead it's a +1, nothing there. Then it's a +1, -1, and then nothing here, and then a -1. Does that sort of make sense? All right. You're just trying to get those averages all around it. So you don't necessarily follow along entirely like how I'm doing it, since you're just trying to get the similar sort of end result there. So let's see. We had just done that one. So now we're doing to the +1s. There. So +1 again. And then this one, we're just getting rid of that. And lastly, we're doing a plus here, and then just the minus. Oh, I mean, just a 1 there. So it creates a very long line. And if you want, you could always just try and find a way to make it so each thing is its own little variable to add, if that's easier to keep track of, since that's what I used to do. I'm just cleaning up those pluses since I forgot I was copy and pasting that. So you have all of those. Do you have them? I think so. All right. So you'll have those two parentheses. Between them, do a slash and then do 8, because you've just put in 8 tiles around it. So we want to get the average, so we just divide by 8. And that should actually work for that. So now we're going to do for the other scenario, where instead it's like just the verticals having the issue. So since you have that line now done, instead of retyping that entire thing, we'll just grab it. And we're going to copy and paste that. So we'll go into this, and we'll look for where we replaced the verticals. Oh, my bad. I forgot. For that one, we did the +1s. We also just do 1 for now. So let me fix that. 1, 1. All right. Because, yep, that looks right. So similar thing here. That's going to be a 1. However, now we can add back in the H tile done. So H tile done -1. So in this next one, we don't need to worry about this 1 for the second part, because we're assuming the X direction is fine. So it's just the Y direction that's having the issue. So wherever you had that 1 before, you can replace that with a plus, like a H tiles done +1. And then if you had it in this first slot, keep it as a 1. So just go through all this. Like here's 1 here, +1, +1, and there we go. So that fixes that issue. If H tile done equal 100. And now we handle in the opposite scenario where it's the X direction only that has the issue. And again, I'm just going to grab the whole line, and I'm going to copy and paste that. And opposite of before, we can do, oh wait, whoops, my bad. That was supposed to be a 1 here. Those other ones fine. Those other ones are fine. So yeah. And that last one had to be anything that said V tile done +1, that had to be a 1. Yeah, sorry, it could be a little hard to track sometimes, my bad. So now we're going to grab our V tile done. And in these ones, it's going to be +1. V tile done +1. V tile done +1. So now we have a 1 here, which makes sense. Oh, we have another 1 here, and another 1 there. So that will handle all those weird scenarios. And now we can just finally make the general one, which will work for pretty much all of them. So again, we'll just grab this, copy and paste it. And now we can just grab, say, the H tile done from before, and we'll just put that in where we put the 1s in the last one. Since this will just be the one where it can do everything around it. So let's see. +1, minus, plus, minus. All right. So that should all work now. it's definitely a little bit of code. And then let's take a look and make sure. Yeah. And we already have the iteration because we copy and pasted that stuff. So with that, all we have to do is go to this bit here, and every time it finishes that whole thing with the V stuff, so it'd just be two indents. We're gonna do tiles equal new map dot duplicate true to make sure it's a deep copy, and then new map equal null. And that can just make sure if you're like getting rid of this, it just saves memory. So because it just gets rid of that. All right. So with that, that's all the smoothing done. And that's like the bulk of the procedural generation for this. And now we're just simply going to make it so it can appear on the screen. So we're going to do var. Actually, I almost forgot. We can just, again, copy and paste this whole thing since we keep using that same sort of thing. Let me get rid of this little thing since we don't need it again. And with that, we'll be iterating through all of them like before. So we are going to be checking, so while, okay, so, oh, wait, that's not what, my bad. That is, oh, if tiles, then v tiles done, each tiles done. And now we're going to be basically checking to see like if it falls within certain ranges to set it to like hard values. So like I make the ocean the like for this, since this is going to be more like islands. So because we're going to want like a lot of water, we're going to make it so like if it's anything like less than like 49, since it was on that like 0 to 100 scale, so that should make a good chunk of it water. We're going to set that actually. I suggest you just take that little thing. I'm getting the reference. Make sure you're able to copy and paste that. We're going to set that equal to 0. Then elif that. So if instead it's less than 52, similar sort of thing, we're just making another little part where it's slightly more like a shallow water. So we're making that 1. That'll reference that. Then instead of 52, now we're going to do 54. So this will start giving us some sand. And then now we're going to do 60, which will be for like our generic like grass or land. So that'll be 3. And if it's also less than 62, then this will be for like sort of hill, so it'll be lightest gray. And then for anything else, it is just going to be equal to 5, which is for like these larger mountains. So that just makes sure everything is more like integer value, so it's easier to work with. All right. And we're going out of that. Actually, was that? Yeah, that was done right. Then one more time, we're copying that matrix. We're getting rid of that random thing again inside of that. And this is where we're finally going to start making it all display. So, let me see, why is that doing it like that? I'll make sure I have this right. Yeah. So, var cell x plus for like position is going to be v tiles done. Var cell y plus is going to be h tiles done. Then var cell atlas position is going to be 0, 0. And then you're going to match these. So match whatever tile we're looking at. Whoops, I forgot I did not have that copy and paste it anymore. So match that. So if it is 0, then we're going to say, because this is going to be basically given the position for like in that tile set we have. So in this instance, 0 refers to like our water, and in that it'll be at vector 2i for 0. And I'm just going to show this real quick so you know for your own reference. So if you go to like your tile set here, you can hover over each one in your tile map, or I think also your tile set will do it. And you'll see it'll tell you your atlas coordinates here and also your source. So if you have to reference your source, which I believe you do, and actually do in the code to place everything down, your source you can see there, that'll tell you it. Any of your atlas coordinates you can put in there. So that's for future reference. All right. So if it's 1, then I'm going to go ahead and just copy and paste that because it's going to be the same thing each time. So instead, it's going to be 3. Let's just copy and paste that whole thing, really. So if it's 2, then we want it to be at 2. If it's at 3, we want it to be at 1. Right. Oh, actually, we want to be at 0 because there's an ordinary dirt one. That's for you to use if you want to. For this one, we're not going to use that. And then for if it's 4, we're going to do if it's at 5. And then if it's at 5, we're going to do if it's at 6. So there we go for that. We're going to get out of that match. And then let me see. Yeah. Then we're going to do our base layer. We're going to do dot set cell. And this will be the last thing we need to do. So we do vector 2i. We're going to do cell x position. And then we are basically going to be subtracting that from, basically we have the width, so that's 100. Or divide that by 2. This is basically so that when you place it on your like your node, instead of everything going from like the start of it like downwards, it'll try and do it so it's like it's all centered on the node. But it can help if you want to spawn everything, like say your player on the node directly, so everything starts centered out. You don't have to calculate that yourself later on. So we got that. Similarly, you can actually just grab that. And we are just going to replace cell X with cell Y. All right. And with that, you do int 1. That's going to be for our source, I believe. Yeah. Then vector 2i. So again, this time it's going to be, we're just going to put in the atlas position we got before. And then lastly, int 0. I can't remember that is. I think it's like a layer or something. And with that, that should be all the code we need. I'm going to go ahead and save this as just the main scene. Let's try running this. It'll take a few seconds, hopefully, but then, oh, what was the issue it had? Oh, it tried to get 100 on this one. It shouldn't have done that. Hang on. So that was the point of this. Let me make sure. I believe I had that right. Let me make sure. Yep. Wait. Oh, whoops, my bad. These are all supposed to be 99. That's why that didn't work. So if you go back to those if statements up there where we were trying to make sure we catch those cases where it doesn't work right, do 99 instead of 100 because you want to get it right before it gets to the edge, not on it. So let's do that one more time. Should do select current. And hopefully now it actually works. We don't quite see anything yet. I think we just might want to add a camera. Camera. Now let's try. No, hang on. Why is that not showing this time? That worked on mine. Let's make sure that's actually outputting real quick. Console. Well, that's not console. That's print. My bad. Print. And then we're just going to print this just so we know that we're getting it. There. Oh, actually, I think I realized what it is. I forgot. Into here, we're going to do a 0. I was working with a different thing where it was 1. That is our source. And there we go. All right. This is what you should be seeing. If I do full screen, it might let me see a bit more. I'd have to add like a proper zoom function. But this is some very basic procedural generation. But you'll have like deeper oceans, you'll have a little bit of shallow, some sand, the like ordinary land, the grass. Then you have your mountains. Do you see some of that on yours?
Oh, I kind of gave up a couple minutes ago. I've just been like paying attention.
Oh, I'm sorry.
Sorry. I'll go back and watch the video.
I can upload this little thing on there, like the file itself, since it'll just be this. But does it sort of make sense how you get this?
Yeah.
And there are simpler ways, like I mentioned before with the noise map. That is probably the simpler way to do all this. This just sort of like helps you understand the process itself, where you're just trying to smooth all those little things out to get more of what you want here. And I will say in some ways, I think you have a little more control over it, since let's say this time I go to that I, instead of doing like 3, I do like 5. So I try to get a little more smooth, but as a consequence, we should see there's going to be more water. Yeah. Because with it doing those averages more, and with it being that there's going to be a lot more water, it's just going to result in it being, the more you do the smoothing, the more you're going to see these smaller islands instead of the larger ones. Does it make sense? All right. Yeah, that's pretty much what I had for this. I don't know, do you guys want to like mess around with it or something, change the value to something random? All right. So in that case, I guess I'll go ahead and just be it for today, at least in terms of this presentation, and I'll go ahead and stop the stream.